Welcome to this essential module on code quality in a pipeline, presented by Dr. Mir Mohammed Asadullah. In today's DevOps landscape, maintaining high code quality is not just a best practice, it's a necessity for delivering reliable and maintainable software. SonarQube has become the de facto standard for continuous code quality inspection, used by companies ranging from small startups to large enterprises like Microsoft and Google. It helps teams detect bugs, vulnerabilities, and code smells early in the development cycle, when they're least expensive to fix. Let's embark on this journey to understand how we can leverage automated code quality checks to build more robust and maintainable applications. By the end of this module, you'll have the knowledge to implement these practices in your own projects and contribute to building a stronger quality culture in your organization. In this section, we'll dive deep into incorporating SonarQube within a GitHub Actions (CI/CD) pipeline. This integration represents a crucial step in modernizing your development workflow and ensuring consistent code quality across your projects. Let's start with the first key step, setting up your SonarQube server. You have two main options here, either installing SonarQube locally or using a dedicated server. I strongly recommend starting with SonarCloud for small to medium-sized projects. It's free for open-source projects and requires minimal setup. However, for enterprise applications or when you need more control over your data, a self-hosted instance might be more appropriate. When setting up your configuration, pay special attention to the sonarproject.properties file. This file is your blueprint for code analysis. Some teams struggle with incorrect configurations that either miss critical code segments or generate false positives. We'll examine the exact structure of this file in upcoming slides. One crucial aspect that often gets overlooked is security. When configuring SonarQube, ensure you're following security best practices, especially regarding authentication tokens and access controls. Store your credentials securely using GitHub secrets. Never commit them directly to your repository. This is a lesson I've learned from real-world incidents where exposed tokens led to security vulnerabilities. Remember, the goal here is to make code quality an integral part of your development process, not an afterthought. By setting up these tools correctly from the start, you're laying the groundwork for a more efficient and reliable development pipeline. Now, let's focus on creating the workflow file, a critical component in your GitHub Actions pipeline. This step is where we define how and when our code quality checks will run. The GitHub/workflows directory is where GitHub looks for your workflow definitions. When creating your workflow file, consider carefully what events should trigger your SonarQube analysis. While it's tempting to run analysis on every push, this might not be the most efficient approach for larger teams or repositories. I recommend triggering full analysis on pull requests and main branch commits, while using incremental analysis for feature branch pushes. This approach provides a good balance between thorough code quality checking and pipeline performance. The workflow file should be clear and well documented. Include comments explaining any non-obvious configurations or business-specific rules. This documentation will be invaluable when onboarding new team members or troubleshooting issues later. Speaking of issues, one common pitfall I've encountered is not properly handling pipeline failures. Make sure to set up appropriate notifications and failure conditions that align with your team's quality standards. We'll explore these configurations in more detail in the upcoming slides. Let's discuss the crucial step of configuring SonarQube analysis in your workflow. This is where we define how our code will be analyzed and what standards it needs to meet. The choice between SonarQube Scanner for Maven and MS Build is significant. Maven Scanner generally provides more out-of-the-box functionality for Java projects, while MS Build Scanner is essential for .NET applications. A key consideration often overlooked is the impact of analysis on build times. Configure your analysis to run in parallel when possible, and consider using SonarQube's incremental analysis feature for faster feedback on pull requests. When setting up the analysis step, pay special attention to exclusions and inclusions. You'll want to exclude generated code, test files, and third-party libraries to avoid false positives and keep your analysis focused on your actual codebase. However, be careful not to exclude too much. Some teams accidentally exclude critical code paths, leading to missed issues. Remember to configure quality gates appropriately. These are your guardrails for code quality, but they need to be realistic for your project's context. Start with reasonable thresholds and adjust them as your team's capabilities mature. The final step in our initial setup involves committing and pushing the workflow file to your GitHub repository. While this might seem straightforward, there are several important considerations to keep in mind. First, always test your workflow file in a development branch before pushing to main. Poorly configured workflow file may cause all builds to fail on the main branch, affecting the entire team's productivity. Create a feature branch, validate the workflow, and then merge it through your standard code review process. When pushing your changes, ensure that your SonarQube credentials are properly secured in GitHub secrets. Double-check that no sensitive information is accidentally committed in the workflow file itself. This is a common mistake that can have serious security implications. Monitor the first few runs of your pipeline carefully. Look for any unexpected behavior, especially around analysis timing and resource usage. Sometimes, what works in testing might behave differently in production due to different data volumes or system loads. Remember, this isn't a set-it-and-forget-it situation. Regular maintenance and updates are crucial for keeping your quality checks relevant and effective. Schedule periodic reviews of your workflow configuration to ensure it continues to meet your team's evolving needs. Let's examine the SonarProject.Properties file in detail. This configuration file is the backbone of your SonarQube analysis, determining what gets analyzed and how. The project key is particularly important as it uniquely identifies your project in SonarQube. Choose a meaningful, consistent naming convention. Using a format like organization may help with project organization and tracking. When configuring source directories, be comprehensive but precise. The Sonar.Sources property should include all relevant source code directories, but be careful not to include generated code or vendor dependencies. The Sonar.Tests property is crucial for maintaining accurate code coverage metrics. Ensure all test directories are properly specified, including unit tests, integration tests, and end-to-end tests. This helps SonarQube provide accurate test coverage reports and identify untested code. For Java projects, the Sonar.Java.Binary setting is critical. Point this to your compiled classes directory, typically target/classes for Maven projects. Missing or incorrect binary paths are one of the most common causes of failed analyses I've encountered. External libraries, configuration through Sonar.Java.Libraries is essential for accurate analysis, especially when your code uses annotations or generates code at runtime. Include all necessary jar files to ensure proper resolution of dependencies during analysis. Continuing our deep dive into the SonarProject.Properties file, let's examine some of the more nuanced configuration options that can significantly impact your code analysis quality. The source encoding property is crucial for international teams. Always specify UTF-8 unless you have a compelling reason not to. Incorrect encoding settings may lead to false positives in code analysis, especially with comments and string literals containing non-ASCII characters. The exclusions and coverage exclusions properties require careful consideration. While it's tempting to exclude problematic files, each exclusion should be documented and justified. I recommend maintaining a separate document explaining why each exclusion exists. From experience, undocumented exclusions often lead to confusion and technical debt. Test inclusions and exclusions are particularly important for maintaining accurate coverage metrics. Be specific about what constitutes a test file. For instance, in a Java project, you might want to include test.java and Java, but exclude test utilities or test data builders. The Sonar.Links properties, while often overlooked, are valuable for team collaboration. They provide quick access to project resources directly from the SonarQube interface. Consider including links to your issue tracker, CI/CD pipeline, and documentation. Let's examine this sample Sonar project.properties file, which represents a typical configuration for a Java project. This example incorporates best practices I've gathered from numerous successful implementations. Starting with the project configuration, notice how the project key follows a clear hierarchical structure. This organization becomes invaluable as your SonarQube instance grows to handle multiple projects and teams. The project name should be human-readable and match your internal project documentation for consistency. In the source directory configuration, we're using Maven's standard directory layout. This is a best practice that makes your project structure immediately familiar to other Java developers. However, if you're working with a legacy project that doesn't follow this convention, you'll need to adjust these paths accordingly. The external libraries configuration using lib/jar is a simple approach, but in production environments, you might need more specific paths. Sometimes we need to explicitly list certain jar files to ensure proper dependency analysis. The exclusions section demonstrates common patterns for files that typically don't need analysis. However, be cautious with broad exclusions like /XML. In some projects, XML files might contain important configuration that should be reviewed for security or quality issues. Looking at the additional project links, these URLs should point to your actual project resources. Maintaining these links may save considerable time when developers need to cross-reference information during code reviews or troubleshooting. This sample pipeline represents a comprehensive CI/CD workflow that integrates code quality checks with your build and deployment process. Let's break down its key components and discuss some real-world considerations. The pipeline triggers on pushes to the main branch, but in practice, you might want to expand this to include pull requests and specific feature branches. Notice the environment variables section. Using GitHub secrets for sensitive data is crucial. Projects may get compromised because of credentials accidentally committed in plain text. The Sonar_token, database credentials, and API keys should always be secured this way. The SonarQube analysis step uses the official Sonar source action. This is preferred over custom scripts as it's maintained by SonarSource and automatically handles many edge cases. The organization parameter is particularly important when using Sonar Cloud. The quality gate check is a critical control point. In production environments, you might want to add more sophisticated error handling and notification systems. I've implemented systems that notify specific teams based on the type of quality gate failure and automatically create JIRA tickets for critical issues. The test failure handling demonstrates good practices for maintaining pipeline transparency. Sending notifications on failure helps teams respond quickly to issues. Consider customizing the notification message to include links to the failed build and relevant documentation. The deployment step's conditional execution ensures that code only reaches production after passing all quality checks. This is a crucial safety net that may prevent numerous potential production issues. Remember to adjust the resource requirements based on your project size. Pipelines may fail because they may run out of memory during analysis of large codebases. Understanding how to properly configure your SonarQube server variables is crucial for successful integration. Let's walk through the process and discuss some important considerations from real-world implementations. When working with Sonar Cloud, the public SonarQube server, the process of obtaining your project key, name, and organization is straightforward but requires attention to detail. One common mistake is teams using incorrect organization identifiers, which leads to analysis failures. The authentication token is particularly critical. Always generate a separate token for each CI/CD pipeline, rather than sharing tokens across projects. This follows the principle of least privilege and makes it easier to revoke access if needed. When storing your token in GitHub secrets, use a meaningful name that identifies both the purpose and the project. For example, sonarkb_token_project name is more maintainable than just sonar_token, especially when managing multiple projects. Consider setting up different tokens for different environments: development, staging, production. This provides better security isolation and makes it easier to track where and how your code is being analyzed. Be cautious with token permissions. SonarQube offers different token scopes. Only grant the permissions necessary for your CI/CD pipeline to function. Analysis tokens don't need administrative permissions, for instance. Let's examine each component of this comprehensive pipeline in detail. This pipeline represents a mature CI/CD process that incorporates code quality as a fundamental aspect of software delivery. The sequence of operations is carefully ordered to provide early feedback while maintaining efficiency. Starting with repository checkout ensures we're working with the latest code. The JDK setup step is crucial. Builds fail simply because teams didn't explicitly specify the Java version, leading to inconsistencies between different environments. The Maven build step comes early in the process because there's no point in running quality analysis on code that doesn't compile. From experience, this ordering saves considerable time and computing resources. The test execution step includes robust error handling. The notification system on test failures is particularly valuable. The SonarQube analysis step is positioned strategically after tests, ensuring we have all the necessary coverage data. This placement also means we're analyzing the exact code that will be deployed, including any test-driven modifications. The production deployment step's conditional execution is crucial. The multiple conditions, push event, main branch, and previous success create a robust gateway that helps prevent problematic code from reaching production. This saves teams from critical issues multiple times. Welcome to the practical assignment portion of our module on incorporating code quality tools into your codebase. This assignment is designed to give you hands-on experience with implementing real-world code quality practices. This isn't just an academic exercise. You'll be building skills that are increasingly in demand across the industry. Proper code quality implementation can significantly reduce production issues and improve team productivity. The assignment focuses on enhancing an existing CI/CD pipeline with SonarQube integration. This reflects a common real-world scenario where teams need to improve existing systems rather than building from scratch. You'll learn how to make these improvements while maintaining system stability. You'll be working with GitHub Actions and SonarQube, two tools that are widely used in the industry. The skills you develop here will be directly applicable to many professional environments. Remember, while completing this assignment, focus not just on making it work, but on understanding why each component is necessary and how it contributes to the overall quality of your software delivery pipeline. Let's explore the key objectives of this assignment, which are designed to give you practical experience with essential code quality tools and practices. The primary goal is to enhance your existing CI/CD pipeline with robust code quality checks. This isn't just about adding another step to your pipeline, it's about fundamentally improving your development process. You'll be working specifically with SonarQube and GitHub Actions. These tools were chosen because they represent industry standards and provide immediate, actionable feedback on code quality. The integration between these tools is something you'll likely encounter in many professional environments. The focus on early detection of code quality issues is crucial. Finding and fixing issues early in the development cycle can reduce debugging time by up to 75%. You'll learn how to set up quality gates that catch problems before they reach production. By the end of this assignment, you'll be able to generate comprehensive code quality reports and use these insights to improve your development process. This is a skill that's increasingly valued in DevOps roles across the industry. Let's discuss the requirements for this assignment. These prerequisites are designed to ensure you can focus on learning code quality implementation without getting caught up in setup issues. You'll need your existing GitLab account from the previous assignment. This continuity is intentional. It reflects how in real environments, we often build upon existing infrastructure rather than starting from scratch. The sample application from your previous assignment will serve as your test bed. This is practical because you're already familiar with the codebase, allowing you to focus on implementing quality checks rather than understanding new code. Your existing pipeline will be the foundation for these enhancements. This approach mirrors real-world scenarios where teams need to improve existing processes incrementally. I've found that this method of building upon existing work helps teams better understand the evolution of their DevOps practices. Make sure all these components are in place before proceeding. From experience, having a solid foundation makes the learning process much smoother and more effective. Let's dive into the first set of tasks for implementing code quality checks in your pipeline. These tasks are sequenced to build your understanding progressively. Starting with the SonarQube server configuration, you have two options: self-hosted or Sonar Cloud. For learning purposes, I recommend beginning with Sonar Cloud as it requires less setup and maintenance. However, understanding both options is valuable. Configuring quality profiles and rule sets is crucial. Don't just accept the defaults, think about what makes sense for your project. When generating your SonarQube token, follow security best practices. Create a specific token for this project rather than using a general one. The CI/CD pipeline update is where theory meets practice. Take time to understand each modification you're making. Moving on to our second set of tasks, we'll focus on implementing and fine-tuning your code quality checks. Defining quality gates is perhaps the most crucial task in this set. These gates will be your automated quality guardians. Start with conservative thresholds and gradually tighten them. Handling quality gate failures requires careful consideration. Your pipeline should fail gracefully and provide clear, actionable feedback. Consider implementing different notification strategies for different types of failures. For instance, security vulnerabilities might need immediate team attention, while code smells could be handled during the next sprint. When analyzing SonarQube reports, look beyond the numbers. Remember, these tasks aren't just about checking boxes, they're about building a sustainable quality culture in your development process. Each step should contribute to your team's understanding and adoption of quality practices. Let's discuss the deliverables expected from this assignment. These deliverables are designed to demonstrate both your technical implementation and your understanding of code quality practices. Your updated GitHub repository should show a clear evolution from your previous pipeline. Include meaningful commit messages that explain your changes. This is a practice that greatly benefits teams during audits and knowledge transfer. When documenting the challenges you encountered, be specific about both the technical and organizational aspects. I've found that this reflection process often reveals insights that help teams avoid similar issues in future projects. Discussing potential applications in your work environment is crucial. Think about how these practices could solve real problems in your current or future workplace. Students use this exercise to drive actual improvements in their organizations. The pipeline documentation should be comprehensive yet accessible. From experience, good documentation has saved countless hours during team onboarding and system maintenance. Include not just what you did, but why you made specific choices. Remember to highlight any potential enhancements you've identified. This shows critical thinking and understanding of continuous improvement principles, skills highly valued in DevOps roles. As we conclude this module on code quality and pipelines, let's open the floor for questions. This is your opportunity to clarify any concepts and share your insights. Common questions may revolve around balancing strict quality gates with delivery speed, Handling legacy code that may not meet quality standards initially. Strategies for gaining team buy-in for code quality initiatives. Best practices for customizing quality profiles for different project types. Don't hesitate to ask about specific challenges you're facing in your own projects. Real-world examples often lead to the most valuable discussions and learning opportunities. Remember, there's no such thing as a trivial question when it comes to code quality. Every query helps build a deeper understanding of these crucial DevOps practices.